Here we have a data set that I found in the list of data sets that are available in StatCrunch. And in this data set, we have a few variables. We have exertion level, light and hard. We have sex, men and women. We have the type of machine that was used for exercise. And then we have the number of minutes exercised. Now, since we can assume these two populations to be independent, men and women, what we're going to do is conduct a hypothesis test on whether or not there is a difference between men and women in the mean number of minutes exercised on these machines. So the question then would be, is there a difference in the average number of minutes spent on an exercise machine between men and women? And let's let alpha be 0.05. So let's draw a picture of our distribution. Now our sample size wasn't particularly large for each, but they were each 12, which then gives us 12 plus 12 equals 24. Now, since our sample size is not at least 30, we're going to have to assume that both populations are normally distributed. And what we're testing then is the difference in these means. So if there is no difference, then when we subtract them, the result would be 0. If there is a difference, then our rejection regions would be out here in each tail, two-tail test, if there is a difference. Because the question is not asking, is the first mean larger than the second mean, or the first mean smaller than the second mean, in which case we'd have either a right tail or a left tail test. It's just asking, is there a difference? So we have a two-tail test here. And so we would break our alpha out into the two tails. So we would have 0.025 in each tail. Now, since that's the case, then we are going to need critical t-values. The number of degrees of freedom will be one less than the smaller sample size. So the degrees of freedom will be 12 minus 1, or 11. We can use the TI-8384 calculator to find this critical value. In order to do that, we'll push second variables distributions, and then we are going to use the inverse t distribution, so we'll push 4. The area will be 0.025 in either the upper or lower tail. And then the number of degrees of freedom we calculated to be 11. And then we'll go down and hit paste. And then the syntax here will be, if you're using an 83 or 84 calculator that does not have that menu option for filling in these values, your syntax would be the area first, and then a comma, and then the number of degrees of freedom, close your parenthesis, and hit enter. And so the critical t-value will be minus 2.201 if we round to 3 decimal places. Let's note that if we put 0.975 in this position, we would get the same value, only the positive result. Let's do that. So second variables, we want the same thing, the inverse t, and let's make this 0.975 now. And then paste that in and hit enter. And just as we expected, since this distribution is symmetric, if we have 0.025 in the lower tail or 0.025 in the upper tail, it doesn't matter. The critical t-value will be the same, just that it will have an opposite sign on the left-hand side. So 2.201 if we round to 3 decimal places. So we have 2.201 to the right and minus 2.201 to the left. Now that we have our critical values, we will need to find a t-test value. We can use the TI-83 or 84 calculator, or we can use a utility like StatCrunch to find that. I've already typed the data values, but in order to do that, you will hit Stat, and then Edit and 1. So this gives you the opportunity to edit these lists, which I've done with the values from the data set. Now we'll push Stat, go over to Tests. I want a 2-sample t-test, so that will be 4. Now it's asking me, am I going to tell it some statistics that have already been measured or calculated, or am I going to tell it some data that are in some lists? And that's what we're going to do. We're going to use data. So we'll highlight that and hit enter. Now it gives us the opportunity to specify which lists. And we did put our data in lists 1 and 2. So we'll leave those the way they are, leave frequency at 1 and 2. Then we want to make sure that we select the correct choice for the alternative hypothesis, which this time will be not equal to. Leave pooled at no, and then come down and hit calculate. And the t statistic that we get, the test statistic, is minus 2.171. So the t-test value is minus 2.171. Let's also note that the p-value is 0.0432. Now in either case, whether I use the t-test value and the t-critical value, or the p-value and the value of alpha, it doesn't matter. We're going to have the same conclusion either way, and that will be to reject the null hypothesis. So we would say something like, sufficient evidence was gathered at the 0.05 level of significance to determine that there is a difference in the mean number of minutes spent on an exercise machine between men and women. We could also use StatCrunch or some other statistics number crunching utility to find the same values. To use StatCrunch, we'll click Stat, T-Stats, 2-sample with data. Now, the column that we are interested in is minutes. But we're going to have to break this out by men and women because the data values are all in that one column. They're all in this 1 minutes column. So where it says where, we're going to press build, and then we're going to select this column, sex, add column, and then equals. And this time we're going to want it to say men. So where sex is men, and then click OK. And then for the second sample, we'll say build, sex, add column, equals, and then we'll select women, add, OK. So now it's been separated out into these two groups. Now we want to uncheck the pool variances box and then hit compute. And we get these same values. We get this minus 2.171 value for the t statistic, and we get the 0.0432 value for p. So either way, whether we calculate this by hand, whether we use the TI calculator or use a utility like StatCrunch, we should wind up with the same values for the test statistic and for the p-value, and wind up with the same conclusion, to reject the null hypothesis. Now before we leave this example, let's do one more quick thing. Let's calculate the 95% confidence interval for the difference in these means. We can do that using StatCrunch quickly by hitting Stat, T-Statistics, ToSample with data. We want the column minutes. We'll put men first and women second. Uncheck the pooled variance box, and this time we'll hit the radio button for confidence interval. We'll do a 95% confidence interval and hit compute. Now let's notice what this says here. The lower limit for this interval is minus 13.434 if we round to 3 decimal places. The upper limit is minus 0.233 if we round to 3 decimal places. But the thing to note about this is these are both negative values. So we're 95% confident that the actual difference between these two, putting men first, is negative always. Zero does not occur in this interval. If zero occurred in this interval, then we would be saying that at the 0.05 level of significance, there is a possibility that they are equal. But since zero is not in this interval, we're saying that they are not equal, which is the same thing that we concluded using our hypothesis test.